So today we'll discuss about the containerization. So what is that, guys? So what is that? Containerization. Containerization. Yeah. So what is containerization, guys? So what is the concept of containerization? So who provides that solution? Docker. Docker provides the containerization solution, right? So before containerization, guys. So what before we are using? Yeah, initially it will be a physical servers. What is this? So initially it will be a physical server, then virtualization, right? Then virtualization, then containerization, right? Yeah. So what is that? So initially it will be a physical servers, physical servers. So then it is a virtualization, virtualization. So then containerization. What is that, guys? So containerization. So what is a physical? How you can interact with the physical servers? How you can interact with the virtualization? So what are the solutions for the virtualization? What are the solutions for the containerization? So how you can interact with this hardware? Definitely we need a OS. Yeah, one OS is installed. That is CentOS or something like. Then you can use this physical server. In the virtualization, the some of the companies, so VMware company. Okay. So VMware provided the virtualization solution and Oracle also. Oracle Virtual Box. So Oracle company also provided the virtualization solution. Right. So we can install the any virtualization software, either VMware or Oracle VirtualBox, right? So you can install the number of OSs. You can install the number of OSs based on the resources, right? Right. Right, guys, this is nothing but a virtualization. So this is the what is a virtualization? Virtualization is the process of running multiple VMs parallelly on a single piece of hardware. Right, this is the single piece of hardware. So we can run parallelly multiple OSs. So here we have a hardware. That hardware is a bare metal on top of which we have host the OS. This is the OS, right? So we have the OS. We installed an application called as a hypervisor on the hypervisor. So we can run on any OS on the guest OS. So here, so we can run the hypervisor. So for example, anything here, we can run the hypervisor. So on top of we can install the any OS. So this is nothing but a virtualization, right? So what is the disadvantage of this virtualization? The disadvantage of this approach is these applications running on the guest OS, we have passed through a number of layers to access the hardware resources, right? So this is the hardware. Hardware uses the hypervisor and that hardware uses the guest OS also. So there might be a chance of slowness because of the OS is that guest OS and hypervisor OS also uses the same hardware, right, guys? So that's so then a innovator thought comes into the picture and containerization comes into the picture. So what is the containerization? So we have a bare metal on top of which we install the OS, and OS we will install an application called as a Docker engine. So here just install the OS. Just install the OS. Here also install the OS, right? So we can run anywhere, something like here also we can install the OS. For example, CentOS. So just run the Docker container, Docker service. Here just run the Docker service and we can run the number of Docker containers based on your resources. Based on your resources. Okay. These all are the Docker containers. So here also just install the Docker engine and you can run the number of containers on your oh, guest OS also. On VM also, just in run the Docker container service, then you can run the Docker containers. Docker containers. So what is a container? I will tell you guys. What is a container? I will tell you. So Docker engine, application Docker engine. So on the Docker engine, we can run any application in the form of containers. So Docker is the technology for creating the containers. What is that? So if you want to create the containers, what is the technology? Who guys? Docker. Who build this container solution? Docker company. So Docker company created a Docker containerization, Docker containers. So the container solutions will be provided by the Docker. Okay. So Docker achieve what is commonly used as the process isolation, that is called all the applications have some dependency on the specific OS. This dependency is removed by the Docker and we can run them on any OS as container if we have the Docker engine installed. These containers passes through the less number of layers to access the hardware resources. Also, organization need not spend money on purchasing the license of different OSs to maintain the various applications. So Docker can be used at the chase of software development lifecycle. Okay. So software development lifecycle. So what is the software development lifecycle for the Docker? What is that? Just build, ship, run. What is that? Build, shift, run. Is the lifecycle of the Docker. Build the images, ship the images, and run the images. And run the images. Okay. First, so you can build the Docker images, then ship it to send it to the artifacts, right? Then we can run the Docker images, Docker containers. Guys, understood?
Yes.
Yeah. Yeah. So for example, Docker, application development stack. So what we can use the application development stack, the HTML content and templates, CSS styles and sheets, client-side JavaScript, including frameworks such as Angular or React, build tools such as Mav and Gradle, web servers such as Apache, server-side runtimes and frameworks, including Node.js, PHP, Python, Ruby, .NET, Java, etc. So databases such as MySQL, MariaDB, SQL servers, MongoDB. Other services for catching messages, Redis and Kafka, Git, GitHub for the source control. So what we need? So for the application development, we need all these, right? We need all these. For example, the libraries. So libraries, we need to install Node.js, PHP, .NET, Ruby, Java, MariaDB, MySQL, Redis, Kafka. So we need to purchase the licenses for the every environment, right? I will tell you the advantages, guys. Okay, setting up the development stack, something like a so front end components, back end components, DB, environment libraries. So right, this is setting up the development stack. Issues with the development stack. For example, this code does not work. He is telling. So well, it worked on my system. So you uses a Mac, they uses Windows. You have developed an app using the Java. They have Java 11 installed. You used MongoDB. They are using 4.2, 3. Using. So there is a mismatch in the dependencies, right? There is a mismatch in the dependencies. So virtualization. What is a virtualization? You already know, right? Here we can install the host OS hypervisor. Here we install the guest OS. Then we can install the libraries like Java Tomcat, Java Tomcat, Java Tomcat. So on that you deploy the application. What are the advantages? Multiple OS in the same mission, easy maintenance and recovery, lower total cost of ownership. But what is the disadvantages? Multiple VMs lead to unstable performances. Multiple, so this is one VM, this is one VM, this is one VM. Multiple VMs lead to unstable the performances. Hypervisors are not as efficient as a host OS. So long boot up process. This is the disadvantage. So the containerization. So the containerization is nothing but you can install the host OS. We don't need to install any hypervisor. You just run the container engine. You just run the container engine. On that container engine, you just run the containers. You can just run the containers. Okay. So containers on the same OS kernel are lighter and smaller, better resource utilization compared to VMs, short boot up process. So VM versus Docker, something like what it will be. So it will be like an elephant. The size should be elephant. Something like the size should be a rabbit. So how it will be the process? Performance will be a tortoise. It is a leopard, cheetah. So right, the integration will be very easy. So what is that? So who will provide that container solutions? The Docker will provide the containerization solutions, right? So what is that? Everything will be in the Docker, right? Front end components, back end DB environment. So we can run anywhere. So we can run anywhere. So working on every system. So works on my system, mine too, mine too, mine too. Okay. Yeah, I will tell you here. Right. So you can run so what is a container? A container contains, a container contains, a container contains base OS and libraries and code. Right. So this is a container. This is a image, Docker image. A Docker image contains the base OS, libraries, and code. Everything will be in the Docker container. So once this is the a Docker image. So from the Docker image, you can run as a Docker container. Okay, you can run as the Docker container. A Docker container is base OS, everything. So your application, OS, mm, libraries, application, code, application code, right? So this contains below 1 GB. Your container should be below 1 GB only. Your container should be below 1 GB only. So here, so how many environments you have, guys? How many environments you have? For example, dev environment, QA environment, and production environment. So this contains Java Tomcat. What is this? This contains the Java plus Tomcat, Tomcat. softwares, right? Libraries means dependencies. Okay, so you have all these things, right? So in the development environment, QA environment, and production environment. What is this? This is the dev, QA, and prod. So if it is a VM or a physical server, every environment we need to install the Java Tomcat, Java Tomcat, Java Tomcat, something like a CentOS, 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 right? So then we can deploy your application. You can install the Java Tomcat, Java Tomcat, Java Tomcat. Then you can deploy the application here. So right here we need to purchase the licenses on each and every environment. And for example, you are you are migrating the you are upgrading the Tomcat and application softwares in Dev in Dev1 QA. So the code will be working on the Dev1 QA environment. After deploying the production environment, it is not working because of the application, the library versions are lower than the Dev1 QA, right? So this is the dependency. So once you can create the Docker image, you can run it in any way. No need to purchase the licenses multiple times. No need to purchase the licenses in multiple times. Once we can create the container, we can run it here, we can run it here, we can run it here. So once you build the image, right, you can push it to the repositories. You can push it to the repository. So for example, what is the repository? Docker Hub is the repository. Artifact tools, guys. What is that? So artifact tool. So whatever the images are pushing. So once you build the image, right, you can push it to the once you build the image, you can push it to the Docker Hub. What is that? Is the repository. Which repository this is? Docker Hub or JFrog or Nexus? Nexus Artifact tool. So Docker Hub registry, we can push the Docker image. For example, this is the Docker image. Or so this is the Docker. So once you created the Docker image, right, you can push it to the Docker Hub. So whatever the environment you want, you can pull. You can pull it to you can pull it, right. So once you create the image, you can run it on anywhere. You can run it on anywhere. Guys, understood? Guys, understood? Pravish, Meghna.
Yes, yes.
Ah, yes.
Yes, right?
Yes.
Yeah. Yeah. What is a Docker? Docker is a platform for packaging, deploying, and running an application. What is that? Docker is a platform for packaging. Packaging means so we can package OS, libraries, and application, then deploying and running. So once you packaging, then deploying the application and running the applications. Docker enables you to separate your application from your infrastructure so you can deliver software quickly. Right, guys. So once the Docker came into the picture, right, there is a microservices and come into the picture. Okay. So so that software development before and after something like so before they are using the monolithic applications. What is that? Monolithic architecture. So monolithic means everything in the single OS. Everything every application will be deployed in the single OS only. Okay, so now it once the microservices came into the picture, so they can divide it into parts. For example, WhatsApp. WhatsApp contains a chat, status, contacts. So before a monolithic application, everything will be in the one So everything will be in the one server. Now something like you can run the microservices. So every component has every module has a container. For example, chat is one container, status is one container, and contacts is one container. If contacts the container, if the contacts container crashes, so nothing to worry about it. So the application will work on the status and the contacts. Before in the monolithic application, if something goes wrong on either chat or status or contacts, entire application will be down. But in the microservices architecture, so whatever the container down, right? That service, that module only will affect. The remaining modules will work on it, right? That is the beauty of Docker container microservices architecture. Okay. So Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. Dockers enable you to separate your applications from your infrastructure so you can deliver software quickly. Docker packages a software into standardized unit called as a container. Docker packages software into standardized unit called as a Docker container that we have everything software need to run, including libraries, system tools, code, and runtime. So by taking advantage of the Docker methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delaying between the writing code and running in the production. Okay. So architecture of the Docker architecture. So from the Docker file, what is that? From the Docker file, you can create our own Docker file and build the Docker images and run as a container. Guys, understood here? So in the Docker file, you can create the Docker file and yeah, for example, yes, guys, cat Docker file. So from Docker IO, so Red Hat, this is the base image. So install the HTTPD, install the wget, install the nzip. So from you can get the software. This is the application software. So then I will send it to the var www html. So expose and need to restart the HTTPD. So right, this is the a Docker file. What this is? This is a Docker file. In the Docker file, once you create the Docker file, then build the Docker images. Okay. So how you can build the Docker images? Yeah. So we want to build the Docker image like as a so educate. We can create as a educate is the name of the image. So once you run right, you can yeah. So you can run as a container. Once the container is running, let's see. So for example, this is the containers. What is this? So this is the container. This is running from last 15 hours upon status, right? So this is a application. So this is one application. This is another application. Okay. You see, guys. So this is the Lab 6A. We deployed the Lab 6A application here. So right, this is the one software educate. This is this is one software, guys. So right, educate is the so we deployed educate in the as a container. You see, so this is the containerized application. Is the containerized applications. Yes, understood. Just I deployed this one. I took from the template. Then I deployed it here. Yes, understood? Yeah, this is the one software, one application we deployed. The other application is something like this is the Tomcat application. This is the HTML application. What this is? This is I deployed from the Apache web server. So this is from the Tomcat web servers. Tomcat web server. You guys understood? So you can run the number of containers. You can run the number of containers. Yes, understood? Yeah, I will tell you everything. No worries. Just heads up this one. How we can run, how we can deploy the containers. So before we deployed this application in the yeah. So before we deployed this application in the physical server, then we deployed in the virtualization server. Now we deployed in the containerization. The same web server, the same application we deployed in the here, lab 6 here. Let's say lab 6 here, lab 6 here. So lab 6 here. Right? Guys, understood. So we deployed here, and we deployed also here also. You guys understood now how it will be? So from physical to virtualization, virtualization to containers. So here we need at least 20 GB, 2 GB RAM, 20 GB hard disk and 2 CPU. But here, so no need, just 1 GB. It will be 1 GB is enough to run the container. Right? A big innovative thought comes into the picture. 90% as cost reduces from here to here, and again a big innovator comes into the picture, and it also reduces the cost from 90% of that one. 90% of that one, guys. Guys, understood? About Docker terminology, guys. Docker terminology is nothing but a Docker file, Docker image, Docker hub, Docker registry, Docker client, Docker container. Okay, Docker file where we can create the file for creating the Docker images. So Docker image is nothing but a your OS libraries and application. You can run this. You can run the Docker image as a container. So your application will be running as in the container. Okay. Docker Hub and Docker Registry. These are the registry or a hub. We can upload or we can download the images from the registry. Docker client. Docker client is nothing but a that Docker software. We need to start the Docker contain stuff software. So Docker complete architecture. So what is the Docker complete architecture? Client, Docker build, Docker pull, Docker run. What is that, guys? So here you can create the Docker build, Docker pull, Docker run. So in the Docker host, a Docker daemon will be running on the Docker daemon. So we can run the Docker as a containers and Docker images. Docker images, right? So what is that, guys? Docker image, Docker containers. How you can check the Docker containers? These are the Docker containers running. You see, container. So this is the one container and this is the one. Two containers are running. Okay, Docker images. So these all are the Docker images. Edurek, Lab 6a, my first image, Jenkins, Tomcat Web Server, Nginx, Tommy. These all are the Docker images. Okay, you see, guys, the size of the Docker image below 1 GB only. Below 1 GB only. Guys, understood? This is the Docker images. These are the Docker containers. Docker containers and the Docker images. Now you understood? So you run as a Docker containers. I run the two containers. One is for educate so application deployment. Other one is the Tomcat deployment. So Docker images, we saw the Docker images. The Docker images will be pushed to the Docker registry. Docker registry. Guys, understood? So first build the image and pull the image and Docker run. This is the complete architecture of the Docker. Guys, understood? Guys, understood? Ravish, Meghna, Shri, Pradeep.
Yeah.
Yep, right? Yeah. So what are the Docker commands? Docker V is nothing but a version. You can check the version. Docker info is nothing but you can help the Docker info. Docker help, Docker login. Login is nothing but so if you want to pull the images to Docker Hub, if you want to push the images to the Docker Hub, how we can push and pull? For the push and pull purpose, we need to authenticate with the Docker Hub registry, Docker Hub registry, right? For that, we can use the Docker login. So it will be communicating between your host machine and the Docker Hub registry. Okay, so Docker images, you can check the what are the images have in that your host machine. So Docker PS is nothing but it's showing the running containers. What are the containers are running? It will show Docker pull image ID. It will pull the Docker image. Docker run image ID. It will run the as a container. Docker build is nothing but to build the image. Docker tag. If you want to create a tag for this Docker image, you can create the tag. Docker push is nothing but to push the images. Push the Docker RMI. So Docker RMI is nothing but if you want to remove the Docker images, you can use the Docker images. So application development, we already know, right? Front end, back end. So in order to deploy our application, for example, collection of program is called as a software project. A project contains several components like front end components, back end components, database components. In order to deploy our application, the mission, we need to set up all the softwares which are required to our applications. OS, Java, MySQL, Tomcat, web server, everything. So in real time, projects should be deployed into multiple environments for testing purpose, dev, set, UAT, pilot, prod. So right, so in every, so for example, a WhatsApp application, so everything we have a UI front end, so web components, business components, persistent components, and database. So right, so for this purpose, we need all these softwares. So DevOps people deploying the application in the multiple environments. So right, so we have in the Git repos, the DevOps people they will be deploying the dev environment, set UAT, pilot, prod. So right, for that purpose, we can install the Linux, Java, Spring Boot, MySQL, Linux, Java, Spring Boot, MySQL. So right, so here each environment having a different versions of Java is a problem. Okay. So if the same Java, same application, same version we have, we don't need worry about it. But if you have a different versions, so there will be a problem, right? Dev environment will be used by the developers to perform the integration testing. Set environment will be used by the testing team to test the functionality of the application. Event environment will be used by client test functionality of the application. Pilot environments means pre-production testing environment. Prod means live environment. It is used for the deliver to project. So to deploy application, these many environments, we need to take off all the softwares required to run our application in the all the environments, which is very difficult to task. So right, then virtualization is come into picture. So installing the multiple guest operating systems in one host operating system, hypervisor software will be used to achieve this. So we need to install the all the required software in host OS to run our application. So this is whole technique to run our application. System performance will become slow in this process. To overcome the problems of virtualization, we are going to for the containerization concept. So containerization, it is used to package all the softwares and applications code in one container for execution. Container will take care of everything which is required to run our applications. So we can run the containers in multiple machines easily. Docker is a containerization software. Using Docker, we will create a container for our application. Using Docker, we will create an image for our application. Docker image can share easily multiple machines. Using Docker image, we can create the Docker container and we can execute it. Guys, conclusion. So what is the conclusion for the Docker? Docker is a containerization software. Docker will take care of the application and application dependencies for the execution. Deployment into multiple environment will become easy if we use the Docker container concept. Guys, understood? Guys,
Yeah.
So install Docker in Amazon Linux. How you can install the Docker? Just sudo m update, sudo m install docker -y service. What are the service we need to run? Docker start. So then user add to the Docker to the group of executing the below command. So just we can execute the command from the EC2 user. Any command from the Docker you can use the sudo. You need to provide the group permission to that EC2 user. Next Docker info. So Docker commands. So Docker commands, Docker info, it will show the Docker info. To see the Docker image, execute below command. So Docker images, pulling hello world Docker container image, just Docker pull hello world. To see the Docker image, Docker images, running the hello world Docker as Docker image, Docker run hello world. Right. So create account in the Docker Hub, guys. So create account in the Docker Hub, guys. Same like so you can provide the email address, then you will get the that one time password OTP sent to the mail. You can provide the mail and just login. Sign up is very easy, guys. Okay, these all are there. This is my repository, Hare Krishna 857, and these all are my images here. So in the repository, we have a private repository and a public repository. In the public repository, everyone we can push the images, something like no. So this is the Tomcat image. If you want, just click it. So right, if you want to download this image from your local. So these all are the examples of Docker. Okay. So you can, if you want to pull that image, you can use the Docker pull Tomcat. Okay. Supported tags respect to Docker files and the references Tomcat. How you can run as a Tomcat. Yes, understood? You can run any OS. You can take the base OS from CentOS. Yeah. So CentOS 7, if you want, you can use the CentOS 7 base image or Ubuntu. You can use the Ubuntu image, whatever you want, guys. You can download it. Okay. Guys, understood?
Yes.
Yeah. So how you can install the Docker? Yeah. Life with Docker. So what is the life with Docker, guys? Something like Docker is a containerization platform. Okay. So Docker is a containerization platform. Docker is used to build and deploy our application into any machine without bothering about dependencies. Dependencies. So dependencies means what are the dependencies? Dependencies means the softwares which are required to run our application. Right. So what are the dependencies, guys? Example, OS, Java, Tomcat, DB software, and Kafka. These all are the dependencies. These all are the dependencies, right? Docker will reduce the gap between development and deployment. Docker will reduce the gap between development and the deployment. So you already know the Docker architecture, right? So what is the Docker architecture? Docker architecture. So what is the Docker architecture, guys? So one. What is the first one? Docker. What is it? A Docker files. It contains instructions to build Docker image. Okay, it contains instructions to build Docker image. To build the Docker image. Contains instruction to build the Docker images. First, you will get the Red Hat OS, then you can install the software, then you can get the application, then unzip the application into MNT. So copy this application into the var HTML. So this is the while creating the Docker images, these steps will be executed. Right. So while running the Docker container, these two steps will be executed. Excuse me, expose means we need to run this application in the 80 port and CMD. CMD will run on the while creating the containers. HTTPD port. We need to start the HTTPD server service while running the container. Right. This is the Docker file. It contains instruction to build the Docker images. Okay. What is the second one? Second one is Docker image. So what is the Docker image? Docker image. It is a package which contains code plus dependencies. So dependencies. So it contains a code plus dependencies. Okay. Notice the third one. Docker registry. Docker registry. What Docker registry? It is a repository to store the Docker images. What it is? It is a it is a repository to store Docker images. So the fourth one, Docker container. So it is a runtime process which runs our application. It is a runtime process which runs our application. So which runs our application. No. Once Docker image is created, then we can pull the image and we can run that image in any machine. Any mission. So once the Docker image is created, then we can pull that image and we can run that image into any mission. Guys, understood? So what is the Docker architecture? So Docker architecture contains a Docker files. A Docker file contains these keywords. I will tell you now one is so Docker image. So what is a Docker image? So Docker file it contains the instruction to build the image. Now you understood. So what is the Docker image? It is a package which contains the code and dependencies. It contains the code and the dependencies. Yeah, we install the dependencies and code. So Docker registry, it is a repository to store the Docker image. Once you create the Docker image, so from the Docker file, you can build the Docker images. From the Docker image, you can push it to the Docker registry. And so from the Docker registry, we can push the, yeah. So from the, so this is the Docker file. So from the Docker file, we can build the Docker images. So these images will push it to the Docker Hub registry. So then we can pull it to the Docker. So this is the Docker image, Docker registry, Docker container, Docker file. Docker Hub or Docker registry, Docker file, in the Docker file, D is capsule guys. So Docker file. So in the Docker file from the instructions, these all are the instructions. So from these instructions, we can build the Docker image. So build, what is this guys? From the Docker file, we can build the image. So from the Docker images, we can run the Docker. So this is the container, Docker container. What this is? This is a Docker container. So this is the Docker container. This is the Docker image, and this is a Docker file. So from the Docker file, we can build the image, Docker image. From the Docker image, you can push it to the Docker Hub or Docker Hub or Docker registry. Then we can pull it to the so any environment run as a container, Docker container. Guys, understood? Docker file, Docker image, Docker registry, Docker container, Docker container. Guys, understood? Is it easy? So very easy, guys. So very easy. So what is the conclusion, guys? Docker is a containerization software. We understood Docker is a containerization software. Okay. Docker will take care of application, take care of application and application dependency. Dependencies for the execution. Okay. Application deployments into multiple environments will become easy if we use Docker containers concept. Docker containers concept. Yes, understood? So for this purpose, what we need, guys? For this purpose, what we need? If you want to install the launching EC2 instance in AWS. So how to launch the EC2 instance in the AWS? So we already know, right, guys? So next one is connect to EC2 using connect to EC2 instance using you already know, right, how to install. Yeah. So next environment setup. How to set up the environment, Docker environment. Set up the environment. Great, guys. So what is the set of the environment? What we need? Create a account in AWS cloud. You already know, right? How to create AWS cloud. Second one is create Linux mission using AWS EC2 service. Okay. Image Amazon Linux 2. You guys can take the Amazon Linux 2. The third one is connect to Linux mission using Put. Fourth one is install Docker software Linux VM using below command. Install Docker in. So what are the commands, guys? You need to install sudo update I, sudo install docker -y, sudo systemctl status docker sudo system start docker. Okay. So then add EC2 -user to docker group by executing the below command. Executing the below command. Sudo usermod -a capital G docker EC2 user. The next is register. Restart the session. Or you can restart the session. Just exit it command. Then check if Docker is installed. The correct one version. If you want to see the info, Docker info, you can use the Docker info command. Yes, understood? So this is the installation setup. So tomorrow I will show you how to install the Docker on Amazon Linux tool. Okay. So this is the setup, guys. So this is the setup for the Yes, understood. So this is the environment setup. What this is? This is a environment setup, guys. Yes, understood. So tomorrow I will show you how to set up this Docker, how to install the Docker. Just install the Docker daemon is enough. In Amazon Linux, CentOS, Red Hat, these all are the inbuilt feature Docker. The default package is available. You can install the default package. Okay, understood? Yep. Thank you, guys. So we'll continue from tomorrow. Okay.